Hello everyone. Today I'll be explaining cat farm optimization. It is a nature-inspired meta-heuristic based algorithm that basically mimics cat's behavior. So we are a group of three people. I'm Siddhant, we have Tushar and Raunak. So this algorithm was proposed by Chu, Sai and Pan in 2006. So first one is the introduction to CSO, that is cat swarm optimization. It is basically inspired by felines, that is, to be more specific, cats. So it derives the information from the swarm intelligence. It leverages the collecting behavior for problem solving. It is a efficient solution search space. The and it is generally used for solving complex problems which are non-linear and has a lot of optimization challenges. So next one is biological inspiration. So this algorithm is majorly inspired by two modes of cat behavior. First one is seeking mode. That basically mimics the resting and careful observation behavior of the cats. It represents a local search strategy. So, so this mode, the algorithm creates small variations of the current solution and basically picks out the best one. So it helps in refining solutions in the nearby area. The next one is tracing mode. So it basically mimics the hunting and chasing behaviors of the cat, and it represents the global search strategy. It is characterized by fast and directed movement of cat towards its prey. So on the next slide, we have a working mechanism of CSO. So as we have already discussed the seeking and tracing modes, basically seeking mode was about local exploration and tracing mode was more into global exploration. So we have to maintain a balance between these two. So the third one is the mixture ratio. So mixture ratio basically maintains a dynamic balance between these two modes, that is seeking mode and tracing mode, so that the most optimal research, so that the most optimal results can be obtained. So here is the algorithm flowchart. So first we have initialization, next we have assign mode, then we have seeking mode, and then we have tracing mode. And in the final, we have a fitness evaluation. From now on, my friend Tushar will take over.
So, next slide. Now we are going towards the next slide. So now we are going to have a look on mathematical formulation. So first is the tracing mode. So here we are going to update the velocity of the cat depending on its current position. So Vi here represents the current velocity of the cat. Xi represents the current position. X best represents the global best position of the cat. C represents acceleration. R is a random number between 0 to 1. So after updating the velocity, we have to update the position corresponding to it. So the position is xi is the current position which we are going to update. Vi is the velocity which we calculated backwards in the tracing mode. After that, we have seeking mode, which is also known as local search. So here we have four points. So first point suggests us copy generation. It generally duplicates the current solution. After that, we have dimension adjustment. It changes a few parameters only. After that, we have fitness evaluation to check how good the copy is. After that, we have to select the best copy amongst the all. So at last, we are going to calculate the mixture ratio. Mixture ratio is the ratio of cats in tracing mode divided by the total cats. So after that, we are going to look at the applications of the CSO optimization technique. So now my friend will the page. So first is the feature selection. Feature selection is used to choose the best input features for machine learning models. After that, we have image segmentation and clustering. It helps to divide us the images into meaningful regions. Then we have route planning and scheduling. It is used for shortest path, delivery routes, task assignment, and job scheduling. After that, we have MLO, which also represent machine learning optimization. It is used to tune hyperparameters like learning rate, depth, etc. After that, we have its use in medical diagnosis systems such as It is used for early disease detection. Don't. At last, we are going to have the point engineering design optimization, which is used in structural design, mechanical design, and extra. Mm. So now my friend Ronak will continue from here.
CSO is a nature-inspired algorithm based on how cats behave, how they explore their surrounding and stay alert. This idea is used to solve complex optimization problems. It has some clear advantage. CSO searches globally, balanced exploration and refinement, and often reaches a good solution quickly. It is a simple to understand and works well even when there are many local optima. But it also has some few limitation. It need proper parameter tuning. The seeking mode can increase computation, and its performance can drop when the number of dimension becomes very high. So next slide. Uh, so in conclusion, CSO is a flexible and effective optimization method. It offers a balanced search, works in many applications, and show how powerful nature-inspired techniques can be. Thank you.